Okay, so hello everyone. We are the RomSpace team. We're the first high school team in our country, and we successfully sent 2 satellites in orbit until now. One of those being Romania's first PocketQube satellite, and the first ever functional satellite that Romania has. So let me first introduce myself. I'm 𝗖cieห์ I study at the International Computing High School of Bucharest, and I'm 11th grade. I will also let my teammates introduce themselves.
Hi, I'm 𝗖cie, and I also study at the same high school as Philip.
Hello, my name is George. I study in the Netherlands at the University of Twente. I'm studying mechanical engineering currently. We will present more about that.
And hi, I'm David. I'm in the 12th grade at the same high school as them, and we also have 2 colleagues who didn't come up on stage right now.
So, as we said, we're a team of students from the International Computing High School of Bucharest. And on our journey with space, we discovered that Romania doesn't have any functional satellites in space, and we wanted to take action. So our main goal was to prove it can be done. Even if we are so young, we wanted to prove that we could do it. And then we wanted to restore Romania's reputation and open a Romanian opportunity for spacecraft industry. So, as we said, RomSpace currently consists of 5 students, but some of our past members that are now studying at universities, they're studying at top universities such as MIT, Columbia, and UPenn. Our past projects, as Philip said, our successful missions are ROM2 and ROM3, which are currently in orbit, and we're planning to launch our next mission, ROM4, next year.
Okay, so this photo is with the team from our first satellite, ROM2, which was our first ever satellite that we sent into space. And as you can see, now this is the team for the next satellite, because most of the students in the last picture are now studying at the university, including George. Okay, so. Okay, so right here you can see ROM1. This is our first ever satellite that we have built. It never flew in space. So ROM is an abbreviation from Romanian Orbital Mission, and also the first 3 letters of our country's name. So ROM1 was a CubeSat. It's not that popular in the nanosatellite scale. There were like 2 or 3 of those flying from the ISS, but at the beginning, when we first started in middle school, we did not have that much of an idea of how a nanosatellite should look like. So we started with a CubeSat standard because it weighed less than a CubeSat, ranging at about 750 grams, and we thought it was cheaper to launch in space. ROM1 was supposed to be launched with a Romanian aerospace company that was developing a steam-powered rocket, which actually never flew in space. But they told us that they would need the satellite quick, in less than a year, and this motivated us a lot to build a satellite in such a short amount of time. So the payload on ROM1 was initially a monolithic telescope, which we were planning on using for deforestation monitoring and other Earth observation missions. But after that, when we found out that the rocket was never going to fly in space, we kind of stopped the development of the satellite, and then we switched on a standard which is smaller, and that is the PocketQube. However, we are also planning to send ROM1 in space, maybe in 2025, on board higher altitude orbit, so we can capture data related to the Van Allen bolt. Okay.
This is RomSpace, our first satellite which made it to orbit. It was launched on a Falcon 9 rocket, to be more precise, the Transporter 8 mission. After brainstorming a bit about the payload, we decided to go with a camera, a 2-megapixel camera. We initially thought studying, again, the Van Allen belt like ROM1 would be a good idea, but due to the small space inside the satellite, we went with Earth observation. As you can see, it's a 1P. It was licensed in Spain because at the time we couldn't do it in Romania. ROM3 was actually licensed in Romania because later we could do it. And it was tested in Madrid for vibration and thermal vacuum.
Okay, so as George told you, it's pretty hard to fit a lot of technology in such a small size. It's actually the same size as a Rubik's Cube, measuring just 5 centimeters, 5 by 5 by 5 centimeters. So here we have a photo of RomSpace while we were building it. So you can see how many wires and how many subsystems go inside. So I would say this was one of the most challenging things in the development of our first PocketQube. And getting all those wires inside was actually a nightmare, but we managed to do it. On CubeSats, you have a lot of space and you have a lot of volume budget that you can put wires for solar panels and a lot of other larger subsystems. But yeah, we had to take a much simpler approach for RomSpace, and we managed to get all those components inside.
Yeah, so this is a video of the Alba pod deploying our satellite and 2 others. Ours is ours will be the one on the left, farther away than the.
It's the one on the left.
Hopefully.
The smallest one. It doesn't work. Okay.
It's okay, just.
So probably you saw this video yesterday on other presentations. This was also the first ever video of PocketQubes in space, and hopefully we'll also get one for ROM3 in the near future. Okay, so I will let David talk about a bit about ROM3.
Okay, so ROM3 is our latest satellite. It launched in orbit aboard the Transporter 9, again a SpaceX mission. It launched on the 11th of November and it got deployed on the 28th. We are still waiting for it to detumble and charge up the batteries. However, it has flown back home, so it is alive. And we are waiting for payload data to come, well, as soon as possible. It's, as you can see, a bit bigger than ROM2. It's a 1.5P. It's basically an upgraded version of ROM2. It has every component upgraded, better solar panels, better battery, 5-megapixel camera, and we basically took everything we learned while developing ROM2 and made ROM3 much better. It also, the vibration and the thermal vacuum tests were done here in Glasgow at Alba's testing chambers, and yeah.
So we also upgraded some issues that we discovered by launching ROM2, such as the RF module. So ROM2 used a 25 milliwatt RF 26W transceiver, and now we upgrade to a full 1 watt transceiver on ROM3 with a built-in LNA. Okay. So here are some photos with ROM3 during the assembly, the final assembly of the flight model. So you can see all the subsystems stacked up. So we even got a larger battery because of the long periods of time that we have to store the satellite inside the deployer until the rocket launches. And after the rocket reaches space, the satellite has to stay alive inside the deployer for actually a pretty long time. For example, ROM3 was inside for about 2.5 weeks. So And here we have a photo of the fully assembled satellite with its antennas deployed. Okay.
This is ROM4, our next project. We will implement what we've learned from ROM2 and ROM3, which were demonstration satellites, but they were successful missions. As you can see, ROM4 will have deployable solar arrays. We will have our main payload as a hyperspectral imaging camera, which will have various applications among deforestations and other things like minerals and stuff like that. We will expect to launch ROM4 in Q4 2024. We do not know the rocket yet, and we will build, like ROM2 and ROM3, an engineering model and one flight model.
Okay, and now we can talk a bit about our future projects, and this is Skyline. So Skyline will be a constellation of up to 10 satellites, which we are planning to send in the future. So as you can see, Skyline looks pretty much the same as ROM4. So our first missions were there just to prove that we can send satellites to space and get signal back from them. They're not the most advanced satellites, but they did their job. We had to prove that we can get signal from space. And using all of our knowledge from those previous attempts, we can then sum it all and start building much more advanced spacecraft, of course, with the help of some other universities and engineers, because such a complex project involves accurate ADCS, complex deployment mechanisms, and a lot of other components. Our first two missions also worked in the radio amateur band. This one, we're planning to have our own frequency and our own ground stations around the Earth. So this is like, it's a project that will start with the first satellite being ROM4, and after that we're planning to finish it in a few years. It depends on a lot of other variables. But the main idea of Skyline is having a constellation of pico/nano satellites, because it's actually the same size as a 6U with the panels deployed. And those satellites can capture pretty high resolution hyperspectral images, because we have already started developing a custom sensor for hyperspectral cameras, and we also started prototyping the lens for it. We're also planning to use a monolithic telescope on board. So after we have those parameters checked, we can also start developing the platform on which we will install the payload. Okay.
Yeah, so as we said before, our missions were to show that we can do it, to show that high school students can send satellites to space and that it can be done. And this inspired a lot of people. And this year at SmallSat, George and Philip met with a teacher from a Georgia prestigious high school. And that high school has a very big astronomy and astrophotography club, which they were looking to expand beyond the horizons and reach outer space with satellites. So they contacted us and wanted basically help from us in developing a framework for making their first satellite. And this is how in this September 10 or 12 kids from Fulton Science Academy came to Romania, where we hosted a workshop and told them about all of the challenges we faced so that they won't have to face them going in blind. And yeah, we basically had a 5-day program of around 5 hours per day, and yeah, we presented both technical and non-technical aspects of developing a PocketQube. And we're still in touch with them. They were looking, last time we talked, to have a radiation measurement payload in the ionosphere or something like that.
Yeah, so we also help them decide on their payload by giving them some brainstorm sessions. And yeah, we basically explain them what it takes to build a simple satellite, as we did. We're not doing crazy science with our satellites, but we build them just to as simple as possible to make sure they work. And this is what we also told them. Okay, so thank you very much. If you have any questions, please ask. Please. Oh.
Congratulations. Congratulations on your team. A couple questions. One, do you recruit new members for RomSpace, or will it end when you guys move on to the university? Do you have younger students? And my second question is, how do you fund your missions?
Okay, so first of all, we are planning of living a generation after we all leave. However, building such projects as a high school team involves a lot of passion, and we did not find any other students in our school that are so passionate about this domain. So we're not sure yet, but we're planning on doing such a thing in the future. And next, the funding. We got funding from private sponsors around Romania, and also a fifth of the budget was, a quarter of the budget was sponsored by our government.
Any other questions? Check it. My name is PhD, about technical. How heavy was your first satellite, ROM2, and how heavy is ROM3?
How heavy was ROM2? Okay, so the weight is in the parameters for pico satellites, and that's about 250 grams.
No,
Oh.
I want the exact number.
Oh, the exact number, 225 grams. Yeah, and ROM3 was under, a bit more under its nominal weight, ranging around 345 grams out of 375, which was the standard.
Anyone else? Thomas?
Hi, thanks for the presentation, and congrats to you guys. It's quite impressive. I know for a fact because I'm heading a master's program for space engineers, and they have a rocketry club, and none of my students are able to do what you do, so big congrats to you. How long was each of the projects from start to finish? Because you have several satellites in the pipeline that are coming up, and you guys are not even 18, some of you. I just want to understand the time frame.
Okay, so it all started when I was 7th grade, and I started getting really interested in this domain of nanosatellites. Previously, I was building autonomous flight vehicles, or UAVs, that were doing waypoint missions, so I had a little amount of experience in the aerospace field. After that, we started building ROM1 when I was 8th grade, and after I did some research for about a year. And ROM2 was started when I was 9th grade, and it finished, it flew when I finished the 10th grade. So it was about a year and a half from development to launch on ROM2, and ROM3 was developed and launched under a year.
Great work. Really like, as I told you, that high schoolers do such amazing things. So 2 questions. One is about redundancy. Do you have any redundancy in your satellite? And please tell us a little bit about your ground station as well.
Okay, so we do not have redundancy, unfortunately. As I told you, the development was really fast. However, on our more complex missions, we are planning on using redundant systems on the important components. Sorry, what was the second question? Oh, the ground station. Yeah, right. So we do have an altitude and azimuth controllable ground station that we installed on the top of our high school. And we are capable of receiving UHF signals on both circular and linear polarization. We have a helical antenna and a cross-Yagi antenna, both equipped with LNAs and SDRs, and controlled from Raspberry Pi. Yeah.
Are you including other people from other people in the reception, or is it just?
So we are also working with the SatNox network, and they are also receiving signals from our satellites whenever they go around their ground stations. So we basically build our ground station just to try to decode things from our own ground station. That's all. We're not relying on our ground station. We're relying on the ones from the network.
Okay, we have time for one last question. Anyone else?
I was just wanting to ask if you would be able to talk further on your Earth observation mission applications for Rom 2 and Rom 3.
So what are their applications?
Yeah, and the Earth observation.
Okay, so our first two satellites, as I mentioned, they're not that advanced, and the main goal was just to receive some photos from them. Unfortunately, Rom 1 did not manage to send any photos. It sent telemetry, like Morse code, and picture packets, which we were not able to decode. But this is what we're trying to do with Rom 3 to get a full image. They're just to prove that we can decode images from space, and that's all. They don't have direct applications. They might have applications in the weather determination and see, for example, hurricanes and stuff like that. That would be like, the resolution will only allow to do that, not much more.